Okay, piecewise functions. A piecewise function is a group of functions, and they are graphed on the same coordinate plane, but they only include certain intervals, and I'm also going to use the word domain a lot here. Okay, so I want you to know the word domain for this as well. Okay, so intervals, domains, same thing. Okay, basically, this part right here, all right, so we've got f of x, and it equals a bracket with two functions, could be three functions, it could be 11 functions really, but we're only going to do like 2 or 3 at a time. Okay, 2 or 3 functions, and it'll say what both of those are. So 2x plus 1 is a function that's linear, and x squared plus 1, that's a quadratic function. Then it could be 2 linears, it could be 2 quadratics. I mean, it could be whatever. It just is what it is. The second part, and sometimes they use a semicolon, sometimes they just space it out, sometimes they'll just put a vertical line there, but the second part of it is an inequality that tells you the interval or the domain. Okay, so these are the functions, these are the interval domain. Okay, now you'll notice that just like any other time we've used inequalities, sometimes you have an equal bar and sometimes you don't. When you don't have one, that means that our ending dot or our beginning dot is going to be open. Okay, our dot is going to be open. If there is an equal bar, that means that the dot we put at the number is closed. And just a little, if we take the O in each thing and use that as a little reminder. Okay, closed. How do you graph them? Well, you put them each into the y equals on your calculator, but then you're going to graph only the values that the interval tells you to. Okay, so again, we're going to use that word domain here, interval / domain. Okay, so let's do an example of this so that we know what we're talking about. Okay, so let's say we have, these are the same 2 functions from the front from the example. And we're going to go into our calculator and go to your y equals. And we'll clear out what's in there. Okay, so 2x plus 1 is the first function that I'm going to graph. Okay, so we'll type in 2x plus 1. Okay, so go to your table. Now, it says x is less than 2 for the domain or for the interval. So I want to look at values for this graph where it's 2, it could be 1, 0, -1, and so on. So I'm going to use my scrolling so that I see all the values where x is 2 or less. So I had to scroll for that. Now, at 2 specifically, when I graph 2, 5, 2, 5, there's no equal bar. So instead of drawing like a regular dot there, I'm going to draw an open circle. Okay, open circle just for that one. Everything else I can do regular dots for. So 1, 3, 1, 3. Let's make that a little bigger, easier on myself here. 0, 1. -1, -1. -2, -3, and I kind of can see this is a linear, this is going to follow a pattern here. Okay, so once I have those dots in there, then I can draw an arrow. Okay, and I will label this part as well. So I will say f of x equals 2x plus 1. Okay, Then I'm going to go to my other function and put that into my y equals. So clear this one out, x squared plus 1. All right, again, hit second table. But this time it's saying that all the x values in my table that I want to graph are going to be greater than 2. So I need to get back down to here, greater than or equal to 2 as a matter of fact. So I got to scroll. Oh, too far. Stop. There's a little bit of lag with this calculator. Here we go. Okay, 2, 5. Now, the idea with piecewise functions usually is that they will, this one, they pick up, one picks up where the other one leaves off. So this function is increasing until it gets to this point, and this point is not included, it's not colored in. But the second one has an equal bar. A lot of times you will see no equal bar, equal bar. That's on purpose, okay? So the x squared plus 1 is going to take over where the linear left off, and it has an equal bar. So this dot that we had not colored in before, it's now going to be colored in because it counts for this graph. So then we've got 3 and 10, and 4 and 17, and then we kind of can't fit any more on here, so we're just going to draw in now remember this is a parabola now, so it's not a straight line. Don't connect it with a straight line. It's going to be it's going to look pretty straight, but it is a parabola. There's going to be a slight curve to it. And I'm trying to draw this with the mouse so it doesn't look fantastic. Okay, and label. F of x equals x squared plus 1. Okay. So something else that your homework asks you to do is, on some of your problems, is to evaluate. Okay. So what if it was f of negative 6? What would that be? Okay, so let's do this from the graph because it's a common sense thing when you see it on the graph. If I go to negative 6 on the x-axis and I follow it down to the graph I touch is the linear one. So in this case, I'm going to sub in the negative 6 to the linear. All right? So let's say all right, let's do that. So 2 times negative 6 plus 1. Okay, so that would equal negative 12 plus 1 is negative 11. Okay. Okay. Let's say I asked you f of 10. Okay, I go over here to the graph. Oh no, if I follow 10, okay, up here I don't get a 10 in either direction. I don't touch the graph. I can't see the part of the graph where it's going to touch. Now, common sense wise, I know that if I follow 10, the linear equation is over here. It's not going to make it to 10. The quadratic one, even though it's going up right here, if I could go up high enough, I could see the 10 where it crosses the 10 line. So we got to have a different strategy for that. All right, so what you do is you kind of think to yourself, all right, so if I was doing 10, I would think to myself, if I put a 10 here, and if I put a 10 here, which one would it be true for? Is 10 less than 2? No, it's not true. So I'm not going to sub 10 in for x here. However, 10 is greater than or equal to 2. So I'm going to sub the 10 in for x squared plus 11. 10 squared plus 11, or plus 1, not 11, I'm sorry. plus 1, and that would equal 101. Okay, but if it equals 101, you can see why it doesn't fit on the graph and we don't see it. Okay, so if you can see it on the graph, okay, -6, if I follow that down, it's -11. I can see it on the graph, and it helps me to know which function I'm going to sub into. But you can also imagine that the number in the parentheses takes the place of the x in the domain interval, and whichever one it's true is where you sub in. Okay, so here's a problem from the homework. I'm going to blow this up a little bit. Okay, and so I have my two functions. Here's one, here's the other. And I'm going to go into my calculator. Y equals, clear out what I had. And the first one is x plus 5, okay? X plus 5. Go to my table. Now the domain or the interval it's asking for is less than -2. So numbers like -3 and -4 and so on. I start at -2. I want that number on there, but then I want all the numbers less than -2. And I'm going to start graphing that. Okay? So there's no equal bar. So -2, 3, -2, 3, put an open circle. Okay? And then -3, 2. -4, 1, and so on. And label. Well, those dots didn't stay where they were supposed to. But x equals x plus 5. There we go. Okay, so that's that part. Okay, then the second part is x squared plus 2x. Plus 3. This time it wants everything from -2 and greater, so I have to scroll through my x values to get those kinds of numbers. So starting at -2. Now, this time there is an equal bar, and we color it in. It's the same point. Color it in. -1, 2, 0, 3, 1, 6. 211 doesn't fit, so we're done drawing in the ones that we can draw in. This is a parabola, so I'm going to start here and draw a curve. And label. Okay, so this is what it looks like. All right, the next part says, is it a function, yes or no? What you're essentially looking for when you're trying to determine if piecewise is a function or not a function is basically, will it pass or fail the vertical line test in any section? Okay, so if it's a function, there's a couple possibilities. Number one, you have dots that overlap. Okay, I have I graph one function and it's an open circle. And the very next function I graph, and I'll do this in a different color so it stands out, the same dot is now colored in because of the second piecewise function, and that's okay. All right, it's a function. Sometimes you're going to graph these functions, and you'll have one function start here and end there, okay? And the other one will not be directly in the same point, but it could be like, say, right above it and colored in. Let's do a parabola there, okay? That's okay. They may not touch. That's still a piecewise function. So sometimes they touch, sometimes they don't, okay? One colored in, one not. Actually, to be honest, this could be colored in blue and red because they're the exact same point, and it still technically passes the vertical line test. Okay, not a function. It's not a function if it is not a function if I graph and this has an equal bar and I color it in, and the other function right on top of it, same exact x value. So the dots are both colored in and they're separate. Both colored in and together is fine. Both colored in and separate, not fine. Okay? The other way it's not a function, and this has nothing to do with dots anymore. We don't care. This example will not matter what the dots do or don't do. If I have one function here, and I have the other one starting over here, and the dots don't matter right now. What matters is that if I pick a spot along here and I drop a vertical line, this fails the vertical line test because the blue and the red overlap. So these are not functions because they fail the vertical line test. These pass the vertical line test. Okay, either they overlap and they're the exact same point and that's okay, or they are one above each other, but one's colored in and one's not. That's a function. So going back to the homework, is this a function? Yes, because it's going to pass the vertical line test. F of 3, okay, here again, you know, you can look at the chart 1, 2, 3, and if I follow this up, I can see that it's going to eventually touch the quadratic. The other way to think about this, if you don't have a picture to look at, because you may not always, is to imagine a 3 in place of the x in both of these inequalities. Okay, so 3 less than negative 2. 3 is not less than negative 2. That's not true. Okay, 3 greater than negative 2. Well, that is true. So that means I'm going to sub 3 into the quadratic. So I'm going to say 3 squared. Switch colors here. 3 squared plus 2 times 3 plus 3. So 9 plus 6 is 15, plus 3 is 18. Okay, f of negative 4, same thing. I'm going to go right back up to these x's, and I'm going to say, okay, negative 4. If I put negative 4 in the place of x, is that less than negative 2? Yes. So I'm going to put negative 4 into the linear and not the quadratic. Okay, so negative 4 plus 5, subbing in, equals 1. And lastly, -2. Well, -2 isn't less than -2. They're the same number. Now, this is -2 greater than or equal to -2. So this is the one, that one doesn't work. This is the one that works because of the equal bar. So I'm going to sub in -2. Now, the -2 for an exponent, remember, has to go in parentheses, plus 2 times -2 plus 3. Okay, -2 squared would be 4. This would be a -4, so plus 4 and a -4, remember that's additive inverse property, equals 0, plus 3 is 3. So that's the main idea of how you do that section. I want to do number 4 in this section because it has 3 piecewise functions in there. Okay, so this one, so I'm starting out with x squared minus 1 for x is less than or equal to 0. So I'm putting in points from 0 and less. So 0, -1. And this is colored in because there's an equal bar. -1, 0, -2, 3, and -3, 8. 2, 3, 4, 5, 6, 7. Okay, just makes it. All right, and this is a parabola. So we got to remember to draw a curve. And then we go on to the next function. Put that in our y equals. And the next part is the part that makes a three-piece function is tricky because it says 0 to 5. So I want to go back down my x values. Here's 0. I want 0, 1, 2, 3, 4, and 5. 0, 1, 2, 3, 4, and 5. Okay, now the 0, let's see, let's switch colors even. Okay, 0, -1. 0, -1. There's already a dot here, and it's already colored in. Now, I know there's no equal bar here. This function is taking over where the other function left off. So it makes sense that they won't both have an equal bar. Okay? So 0, 5 is a point. Okay, I'm just going to reinforce that that point is there. And then 1, 1. 1, 1. 2, 3. 3, 5. We can kind of start to see a pattern. 4, 7. And 5, oh no! 5, 9. Probably should have had this x-axis count by, or y-axis count by 2s. Okay, now I'm not going to put an arrow here, but I am going to color in the circle. All right, this last part says f of x equals 3. Just 3. Okay, which is weird until you remember when I taught you hazy and Vixen too, but we're only going to use hazy for this assignment. Hazy means that if you have y equaling a number, it makes a horizontal line. This is really hard to write words with the mouse. Horizontal line. So I want to start at an x value of 5. 1, 2, 3, 4, 5. The y value is always going to be 3. So I'll go to 3 on the y-axis. I'm going to draw an open circle because there is no equal bar. And it's all values greater than 5. Okay, so here's a great example of where I have a piecewise function that comes down and this blue piece takes over where the purple piece left off. This piece right here, in fact, let me change colors of this so that I can talk about it in terms of color. Okay, I've changed this to red. All right, this red piece technically is taking over for where the blue piece left off. And see how they are on the same x coordinate line. But the blue one is colored in because this had an equal bar, and the red one is not because it did not have an equal bar. Okay, and lastly, we definitely should have labeled all of the pieces of the function. So this is the f of x equals x squared plus minus 1. This part over here, come on, let me make another text box. And this part over here, so we got all the f of x labeling, the x squared minus 1, and the 2x minus 1, and the 3. Okay. Lastly, is it a function? It's passing the vertical line test, so yes. F of negative 2. So again, we're going to put this negative 2 in place of all of the x's here, and we're going to find the one that it's true for. So negative 2, is that greater than 5? Well, no. Is negative 2 in between 0 and 5? No. Is negative 2 less than or equal to 0? Well, yes. Okay, and if we go to negative 2 over here, we can see if we follow it up, it touches the quadratic. We can see the answer is going to be 3, but I want you to still show your work. So we're going to do negative 2 in parentheses squared, okay, minus 1. So positive 4 minus 1 is 3, which we could see on the graph. Okay, oh, tricky, 0. Where would 0 go? Okay, so 0 here, 0 here, 0 here. Well, is 0 greater than 5? No, so it's not that one. 0 does not fit here because there's no equal bar. So that's not it. 0 less than or equal to 0. Well, they're both 0, but since this has the equal bar, this is where that statement is true. So again, I'm going to use the quadratic. 0 squared minus 1. So 0 times 0 is 0. Take away 1 is negative 1. And 5. So is 5 less than or equal to 0? No. Is 5 less than or equal to 5? Yes. Is 5 greater than 5? Nope. So this is where it worked. 2 times 5 minus 1 is 10 minus 1 is 9. So lots of good things to see in this question. And remember that if you have f of x equaling a number, that means a horizontal line. Okay, and it starts on the domain number and follows the y value of that. So we started on 5 because that's my x value, and the f of x is 3, so we go to the 3 and start there and go across. Have a good weekend. Make sure you remember your mothers or your grandmothers or a special aunt or just a special mom type figure in your life on Sunday. And enjoy.